Hey folks, my name's Jeremy Justus. I'm a senior software engineer at Optum. I've been working in the API and API gateway space for about 4 years, and I'm excited to be one of the first Kong champions.
And hey everybody, my name is Ross Sbriscia. I was hired directly out of college by Optum just over 3 years ago. I've been working in the API and API gateway space ever since, and I'm also proud to say that I am one of the first Kong champions. Now, since our talk is largely focused on Kong and open source in large enterprises, and Optum in particular, I think it's only fair that we give just a little bit of background on Optum itself. So, what's Optum? Optum is a large healthcare services and technology company. It's part of UnitedHealth Group, and one of its important responsibilities is to provide the technology infrastructure for this Fortune 6 healthcare giant. And I mean, you can see, I don't need to say this, but just for a sense of scale, 300,000 employees, thousands of APIs, countless integrations with internal and external systems. There really is a lot going on in this environment. So let's focus in on one particular space, and let's start talking gateways. Primary API gateway solution for UHG in the final months of 2017 was a closed source vendor product. It had been the primary solution for almost 4 years at that point. And over the course of the preceding year, we've been noticing a number of increasingly concerning stability, scalability, and performance issues with the platform. These, in conjunction with the natural relative low supportability of the solution, meaning that it was difficult in some cases and impossible in others to innovate around it to enable things like DevOps, and the high costs associated with the solution, which in this case means three things. First, the product itself was pricey. Second, the product was relatively resource inefficient and required quite a lot of infrastructure to run. And third, and this is largely a result of the supportability issue, the operations team required to maintain the solution was quite large. And so, needless to say, at this point, we were considering replacing the solution. But before I quite go there, I need to touch on something that really shouldn't go unsaid. And that was, at the same time as we were coming to this realization on the gateway team, there was a larger organizational change going on in Optum with respect to open source. UnitedHealth Group has its roots in insurance. And insurance is a business focused on the mitigation of risk. And for a long time, open source was seen as a risk, but that was changing. There were voices from all across the enterprise, everybody from engineers to lawyers to architects, and importantly, people in the positions of power and influence. And they were saying things like, well, what would happen if we really started to invest in these open source solutions and devised internal processes which could be supportive of their adoption? Like, what's possible with these products? And it's because of this change in mindset that we ended up with a selection criteria for our new gateway solution that looked more or less like this. We were interested actively in adopting an open source product as opposed to a proprietary solution. We were interested in the extensibility that this would provide us, as well as, frankly, eliminating the licensing costs associated with our existing solution. We were looking for a cloud-native application, something we could use to support a modern CI/CD pipeline with decreased recovery time in the event of incidents and better scalability. And finally, we were looking for a more performant solution than our existing. We weren't quite satisfied with the performance of the existing solution, and even some of our internal customers, that is, the API providers within Optum, were complaining about it. And so we really wanted to focus on something that was more performant and much more resource efficient than our current model. Now, if this sounds kind of familiar, it should, because I think this describes Kong pretty well. And I thought so too at the time, which is why we decided to POC Kong. And in the interest of time, I'm just not going to go into how exactly we chose Kong as opposed to some other products. And instead, let's take a look at what was required once we had decided that we'd like to POC Kong to bring this application into a production state.
Right, so what are some of the initial hurdles we faced when bringing a newer open source technology like Kong into an older established enterprise? Well, the first was being able to gain the approval of leveraging the open source product within our network. So that came down to a lot of formal documentation of the application and its capabilities within an internal portal that other teams and people within our company could go to also leverage the product. So after we did that, we then moved on to essentially security requirements. So when people and users call us from the public internet, we have to worry about, malicious actors. So luckily for us, we already had a web application firewall solution that we were able to integrate as part of our ingress into the API gateway architecture. And finally, we iterated with policymakers on a new flow where we used to have 2 gateway hops to reach a lot of our services. We were able to cut that down in half with 1 gateway hop before clients could reach our services, thus just improving latency out of the box for us. After that, we did some initial tunings around Kong and kind of established some central patterns for how we wanted to leverage the gateway. One being we wanted a singular OAuth token generation endpoint that all clients could leverage, because our older established gateway solutions all leveraged a single client token generation endpoint, which was better for documentation as well for customers. And then we also worked with the Kong config template to work on things like tweaking the buffer sizes, as well as better TCP and socket connection management. After we had done some of that, we then moved on to wanting to make sure that if we're going to offer this service to UnitedHealth Group's APIs, we needed really robust, high availability and disaster recovery baked into our architecture. That was really important to us. And early on, we had about 3 rudimentary alerting, telemetry, and monitoring solutions in place for the gateway. And I would say by now, we're probably integrated with close to 10+ logging and alerting and solutionings, basically giving us unparalleled visibility into the gateway at runtime.
All right, cool. And that leads me really nicely into the main question that we'd like to try and answer as part of this talk. And this is something that we heard from voices across the org when we announced that Optum's new API gateway solution may be an open source product. And the questions were all variations on a theme, and that theme was, how can we, as a large enterprise, have confidence in open source products, and particularly in mission-critical roles? And so I'd like to bring up a number of ideas as part of our answer, the first of which is to cultivate internal experts. And to understand what I mean by that and the value this can bring, let's think for a moment about how innovation happens. I happen to believe that innovation is a natural consequence, really, of expertise and inspiration. Inspiration is a bit tricky to pin down, so let's focus in on expertise in these products and take a look at both a closed source and open source model and see where the expertise comes from, starting with the former. So in a closed source model, expertise is rendered by experts who are effectively rented and only offer their expertise on specific request. This means that they can only react, but not innovate, which is further hampered by the fact that these experts are not familiar with the specific conditions of your environment, the integrations you need to support, the customizations you already have. This is bad for 2 reasons. First, yes, it does hamper innovation, and secondly, in the event of a live troubleshooting scenario, it significantly decreases the efficiency with which these engineers can approach the problem because they need to familiarize themselves, very likely, with your environment before they can be effective. And all of this is just exacerbated by and made much worse by the fact that the product itself in a closed source model is opaque, which artificially limits your team's understanding and makes it very difficult to produce effective and efficient integrations. Now, let's contrast this with the open source model. In an open source model, when we're cultivating internal experts, these experts have the opportunity to leverage their skills and expertise for the benefit of the entire space, the solution itself and all of its integrations. This is bolstered by the fact that these experts are fully versed in the specifics of the environment they work in, and all of this is enabled by the fact that the product itself is entirely visible and your team has no limits on its understanding of the solution. So the question kind of becomes, how do we actually go about, in a practical sense, cultivating these internal experts? And this kind of leads me to the second idea that I'd like to bring up in the context of having confidence in open source products in large enterprises, and that is that of community participation. Now, this gets thrown around a lot in the open source community, and we decided that to help organizations that were maybe thinking the same way now as we were a few years ago, it would be beneficial to give a very detailed and specific example of what can happen here. And so we chose one of our more accessible examples of an interaction with Kong, which happened to be our very first interaction with Kong, and it went something like this. One day we were working in the environment, and one of our internal customers comes to us and says, "Is the gateway having any issues? It looks like we're receiving some HTTP 502s during our testing, but the weird part is we can't find these transaction logs in Kong's logging solution." And we had integrations with an internal logging solution using the HTTP log plugin. That'll be important in a minute. So we took a look, and we said, well, we found the results in our logs, but they were in the standard out logs, and it looks like you're receiving a transport layer failure, specifically a connection reset when we're trying to route to your upstream service. So we let them know, and they got to take that back and diagnose what's up with their deployment. But for us, we're left a little bit concerned. We want to have logs of these failures, and it's arguably more important to have logs and records of these than it is for successful transactions. And so just kind of put yourself in our shoes at this point. We had worked almost exclusively, if not entirely exclusively, with vendor products throughout the course of our whole careers. So in a situation like this, we would have been tempted to, many of you know the drill, make a support ticket, get some logs together, maybe get a meeting in a couple of weeks to talk about the problem. In this case, we decided to make a post on Kong Nation, and we said, hey, it looks like on Layer 4, transport layer failures, the Kong HTTP log plugin just isn't logging the events. Does anyone know why? And we weren't quite sure what to expect when we did this. We weren't sure if we were going to get a response in a couple of weeks or a couple of months, if it was going to be intelligible or helpful at all. So imagine our surprise when that day, none other than one of the principal engineers for Kong itself, Mr. Tebow, responds and says, hey, give this a shot. See if you can just put this little code snippet in your error handler block and see if that doesn't do the trick for you. And so we thought, wow, this is great. So we grabbed this code snippet, we put it in our nginx.conf, we rebuild our dev environment, and it didn't work. Undaunted, we made another post on Kong Nation describing exactly what we tried in as much detail as possible and included all of our sources. And the community responded again, and Tebow says, well, I may have spoken too soon. It looks like Nginx's error page is doing this internal redirect, resetting Nginx context and preventing plugins, including the HTTP log plugin, from running. And we said, you know what? We think we can roll with that, maybe. And so we took it back, and we did a little investigation, and we found something. We made another post, and we said, we may have found something interesting in a similar open source product. Turns out, there's this library which may allow us to share Nginx context between these sub-requests. What do you guys think? Can we build this into Kong somehow? And an engineer that we hadn't worked with up until that time, but I have since gained great respect for, Mr. Bungle, comes back and says, well, we took a look, and we have two solutions. One of them incorporates your suggestion. Let us noodle this for a bit, and we'll get back to you. All right. So not too long after that, we saw a PR be made and merged by Kong, which contained a solution that adopted our suggestion, and we were informed to expect this in an upcoming release candidate in just a couple of days. So great. So we're thrilled at this point. But a lot just happened there, and I'd like to unpack this just a little bit so we can highlight an important interaction. So what really went down? First, we had a problem. Next, we investigated that problem. Third, the issue came back to something in Kong, and we engaged with the community on that issue. The community suggested a solution which we attempted, didn't quite work, so we re-engaged the community. They provided us some feedback, which we used to inform an investigation. We suggested a solution based on that investigation, and the community confirmed that solution. Now, what I'd like to draw your attention to is the fact that this step occurs twice. So why did our first investigation of the problem yield such a different result from the second investigation of the problem? What changed? Turns out that what changed, at least for us, was the nature of the problem. It went from being in a closed source mindset, oh, there's something wrong with this Kong thing, to, all right, very specifically, when we're going through these internal redirects, we're losing Nginx context. And I'd like to just draw the comparison between that little piece of knowledge that we took and ran with through this interaction with what we might have achieved and what we might have benefited from ultimately if this interaction was with a closed source vendor product institution. I don't think it's going too far out on a limb to say that we probably wouldn't have cultivated too much expertise in that interaction. And so if we want to take ourselves to the next level, the next thing we need to do is start contributing back to the community.
Yep, so let's look at a scenario where we ran into something and it led to us being able to contribute back to the core of Kong. So I was just working on regular gateway things one day, and a customer reaches out and basically says what customers always say: oh, is the gateway broken? Something's down today. Calling my APIs. I'm seeing HTTP 431s. Testing my API directly, it's working fine. What's going on? So, I start looking into it. I realize, HTTP 431, well, there must be some headers that are getting sent too big back to your web server, so it's just reaching the header buffer limit size and rejecting the transaction. So I started doing a little bit more digging and realized that there's the ACL plugin in Kong. And the ACL plugin, by default, will include something called X user groups. So with this header in mind, in our architecture, for every Kong proxy we have, there's a route resource. That route resource has a UUID. We use those UUIDs to inform how customers have access to different proxies. So you can imagine in a large enterprise, when you have lots of proxies, say hundreds or thousands, that header is going to get filled with what? Hundreds or thousands of UUIDs. So knowing that and knowing how it was growing in size and could potentially cause HTTP 431s like in this scenario, I raised a nice little Git issue to Kong, discussing a couple of points, and bringing up the idea of, well, maybe this header value could just be configurable, disable, enable it. Lo and behold, an engineer I respect from Kong, Mr. Bungle, came in and said, I'd give the thumbs up for that change, worthwhile change, implemented in the ACL plugin. So now that I'd worked with Kong for a little while, I started understanding a good number of portions of the code base, and, courage in my heart, I decided to go ahead and get into the code and figure out where in the plugin I could make that adjustment. And it was great. Thibault looked it over, merged it in, and it all was awesome. It's pretty cool to be able to commit something back to a code base that I knew then other people in Kong may not even know this interaction had happened, but they're going to benefit from it regardless. But even better is that being in open source and being the fact that every change that goes on in an open source product has lots of eyes on it, another member from the Kong team just reviewed it and was like, hey, I think we could go even further with this. You may have stopped the header for being passed to the back end and solved for your use case, but down in the Lua level, there's also this variable that's getting set to all those UUIDs under the hood. But if we're enabling your configuration to not set that header to send to the back end, we can just set it to an empty string and save on Lua memory pressure as traffic's going through Kong. So with that in mind, and he gave me a nice little code snippet to test, since my other PR had already been merged at that point, I did a follow-up PR just implementing his suggestions. Now, one thing I want to point out that may not have been noticed in those two PR examples is the timings on them. They were merged the exact same day I, as just some third-party contributor, sent them off to Kong. And that kind of turnaround time is phenomenal, and I think it's one of the driving reasons you're seeing open source gain such popularity in the space. You just don't see such kind of turnaround times in a lot of older vendor-centric models. So with that in mind and our expertise growing in Kong, it was very important that we offer this gateway service internally as a product to our customers. So what exactly does that mean? Well, for us, we took a very docs-first approach. So this has two main benefits. When we were a small team of 2 engineers, you just can't join customer calls constantly with Q&A sessions about how to leverage the gateway. So with our docs, which had really robust details on how to leverage the gateway, it freed up time for us as engineers to focus on the code and customers to be able to integrate with our application and honestly to really build their own engineering culture around our product, because we didn't go in and say, you need to do X, Y, and Z against our gateway, and that's how you're going to hook in. You review the docs and then innovate around what we're offering for how you want to leverage it within the company. And now I want to talk a little bit about kind of the operations modernization of how we've had when working with this gateway. When we first started off, we had just productionalized the gateway. There was no ecosystem around the gateway we were offering. So what did we do? We had an email distribution list that we would work with customers. So when we had 4 to 5 customers, it was all right communicating through email to do things like creation of proxies, authorizing consumers, and managing things that way. As we got more and more consumers, that became quite the nightmare. You got people responding to the wrong email chains, everybody responding at the same time to the same email. It didn't work out very well. So we iterated one more time, had a work ticket queue processing, first in, first out kind of setup. Customers didn't have any visibility hardly, though, into the progress that had been made on their tickets. And at the end of the day, the root problem is you have a human making the request, a human trying to process that request, and the miscommunication and typos that comes from that. So we iterated one more time into a process I think that we're pretty happy with now, which is our GitHub Ops self-service model. And this is a solution that basically customers do PRs into a GitHub repo. This kicks off an intelligent agent via a webhook, and then we process on those resources against the Kong Admin API directly to create what the customer needs. So what you're looking at right here is a very high-level view of the self-service flow. Very, very importantly is the first bubble. Customers do need to read the docs. If they don't read the docs, the amount and sheer number of questions they would have for the engineering team internally here, me and Ross, would just overwhelm us. So step one, most important step. But after the customer reads the docs on how to leverage it, they would then make a PR to GitHub. That's going to cause a GitHub webhook to kick off to our intelligent agent to then go and review those resources that were submitted by customers. If the resources show, post is valid through our taxonomy and governance program, it'll call the Kong Admin API to produce the proxies, produce the consumers that they want to create, and then it'll comment on that PR, PR merged, successful, and post back the resources to them to show them that it was created. Otherwise, if there's problems, it'll also do a comment on the PR to say, hey, you need to fix this or you need to fix that. And it provides a really nice little feedback loop for customers because they can then constantly fix their request until it's perfect and gets merged in and processed without us having to have lifted a finger in that interaction. So what you're looking at right here is kind of some high-level self-service resources that we worked with in this model. We have the namespace resource, which boils down to essentially a Kong consumer and then credential pairs for calling the proxies. So with that in mind, it eventually comes down to a Kong username, a couple of contact informations, as well as access control that hooks into internal company access systems. And then we have a proxy resource, which just boils down to creating a Kong service, a Kong route, and any plugins that the consumer would have needed. And one thing about that is it's also nice because with that high-level abstraction, what you have is you have the resources there, but the consumer doesn't actually have to know the underlying technologies that we're working with, right? If you understand an API gateway, you would be able to use that intuitively. So some of the results of our ongoing journey here. So with the self-service adoption now, we have over 300 unique users leveraging this internally, 2,000 interactions every month. So that equals 2,000 interactions that we didn't have to manually talk to a customer and work with them to process on their proxies, their resources. They're driving it all themselves, and it just frees up a lot of time for our engineers. As well as we really like the kind of native GitHub integration to where you can tell who's changed what resources when and why. As well as our self-service tooling integrates with things like Prometheus and Grafana to create Grafana dashboards on the fly with alerting baked in so API providers can know when their services are failing as soon as they start failing. And then this is kind of the thing I think everybody likes to know is your sense of scale when you're working with Kong API Gateway technology. This is where we are and where we're going. And we have lots of APIs, lots of consumers, high level of transaction volumes, and we are fully confident that Kong is going to be able to support our needs all the way through this journey.
All right. So this is a completely shameless glamour slide here. If you want to show somebody one slide that gives context on how much Kong helped Optum. This is the slide to show them. And let's just jump right in. So let's talk about performance. Kong has produced an 85% reduction in gateway overhead compared to our previous proprietary solution, in addition to being 90% more resource efficient. And you can kind of see that here. What you're looking at is a graph that shows the results of 3 separate comparison tests. In the blue, a test against an API directly. Happened to be a Golang API. It's pretty fast, with an average response time of 6 milliseconds. In the orange, the same API with a Kong proxy in front of it, average response time is 17 milliseconds. And it's only really until you look at the skyscraper on the left that you can kind of visualize exactly how much better Kong is than our previous solution in terms of raw performance. This kind of brings me into cost, which is another big one, especially for enterprises. Obviously, going from a proprietary licensed solution to Kong Community Edition eliminated our licensing costs, which is a good thing. And the fact that Kong is more extensible, and we were able to engineer these DevOps enabling tools around it, has allowed us to reduce our operation staffing by 85%. That, in conjunction with the fact that Kong is much more resource efficient, meaning we can run with less hardware, the same capacity, has resulted in a whopping overall reduction of 95% in terms of the cost of the API gateway solution in Optum. I can't go into specific numbers, but just trust me, it's a truckload of cash. In terms of supportability, like I was talking about earlier, you're looking right now at the entire Kong team at Optum. This is it. It's on stage. In the last couple of weeks, the team's grown a little bit. For almost 2 years, we were supporting the operations needs of a 300,000-person company, in addition to pursuing all of our engineering goals, getting those monitoring, alerting things set up, iterating every time a new version of Kong came out, iterating on that version of Kong, make sure we were getting it tested. So if this is possible, it's clear that we're dealing with a high-quality product with DevOps in mind. And let's wrap up by coming back to the question that we started this whole thing with, which is, how can we, as a large enterprise, have confidence in these open source products, and particularly in mission-critical applications? And so here's our answer. Step 1, set the stage. Ensure first that you have a company culture which is curious, maybe even excited about open source products. And if you don't have it, start it. Revisit any existing integrations that you might have had with the previous solution. See if there's some low-hanging fruit for you to try and tackle. And offer a stable solution from the start. This is how you can start off confident. How you can stay confident is by cultivating internal experts. This enables you to innovate and improve around the solution itself and also all of its integrations within your environment. The way you do that is by participating in the community. This does 2 things. It helps you share knowledge and expertise both from yourself with the community and vice versa, and provides you an avenue for solving problems that you might not be comfortable solving on your own yet. Where you take yourself to the next level is by contributing back to the community. There's no better way to hone your expertise than by getting direct feedback on your literal work, and the community benefits from this as well. Finally, offer a complete product to your internal customers. Enable an engineering culture by providing a docs-first approach, keep your standards high, and you will enable your internal customers to innovate and engineer around your solution in the same way that you can innovate and engineer around the open source product in general. And that's it, everybody.